Before we keep going, let's quickly summarize where we are. We are still at the very first step of our process of implementing TensorFlow on the Google Cloud using Cloud ML Engine. So we are in the setup step where we are connecting to Data Lab on the Google Cloud platform, and we are then going to query a public dataset within BigQuery in order to set up our model. What we've done so far is to connect to Data Lab and clone the source code. The next item on the agenda is to query BigQuery for that data. So let's switch back over. We've clicked on our IPython notebook, and the data set that we are going to work with has data for taxi rides in New York. This is a public data set, which means that anyone can access it from any project. Before we actually get to the data, let's quickly walk through some of the code. Notice up front that we have a bunch of import statements. These are very much like you would expect to see in any Python program. For instance, we have pandas, that's for data frames. We have numpy for matrix multiplication and manipulation. We have seaborn for some visualization. The interesting one though, which we've not come across before, is the import of datalab.bigquery. This is going to allow us to interface directly with the Google Cloud Platform's BigQuery offering from within our IPython notebook. As always, while opening up a new Python notebook for the first time, it makes sense to clear all of the cells. This will get rid of the cached results. Let's go through and start running the contents of this notebook one by one. First are the import statements, and then is a fragment of JavaScript which the folks from Google have embedded. In any case, let's move on now to the BigQuery parts. Here we can see right off the bat that there is a reference, a link to that BigQuery public dataset. Let's click on that dataset and explore it. As we shall see, this dataset includes columns for the pickup date time, the longitude and latitude of the pickup and the drop off, the number of passengers, the trip distance, the amount paid in tolls, the fare amount, and the total amount. We are now going to explore this data, filter it, clean it in many different ways, remove some of the columns, and then set up a fairly standard regression problem in which we will try and predict the fare amount, that's the y variable or the dependent variable, using some of the other columns such as the pickup and drop off longitudes and latitudes, the passenger count, and the distance. So this is our basic problem setup. Let's go ahead and implement it. Coming back to the code, we can see that we have a SQL element right up there, and this SQL element has a %SQL tag followed by something which looks very much like a comment. That's the bit in green. Don't be confused though, because it's not a comment. What that little bit in green is going to do is it's going to execute the query which follows and save the results in a variable called a few records. So that's not a comment at all. The variable a few records is going to be referenced in the very next line of code. And that line of code makes use of the BigQuery connector. So it executes that query using the variable a few records, and it converts the result set that we get back into a pandas data frame. That pandas data frame is assigned to the variable called trips. Let's go ahead and examine the contents of the trips variable, and we can see that it's a pretty normal pandas data frame, and the columns do indeed represent the data that we just mentioned a few moments ago. We notice that within this data, we definitely have some work to do. We can see, for instance, that there are a whole bunch of rows where the trip distance and the fare and all of the relevant fields are 0. In any case, we'll get back to the exploration and cleaning of the data in just a little bit. For now, let's keep going with just fetching the data. While doing so, we would now like to sample it so that we only access 1 in every 100,000 records. Why are we sampling only 1 in every 100,000 records? Because as that comment tells us, there are 1 billion records in this public data set, and so we do not want to fetch all of that data back into our data lab session. That would be way too much for us to handle. What we would like to do is to fetch 1 in every 100,000 records, which would give us about 10,000 records in total. Let's go ahead and do exactly that. Let's make use of yet another SQL statement. In this one, we are going to hash the date time, and we are going to set the number of buckets to be equal to 100,000, and we are only going to pick those data items which have that hash value equal to 1. So that will give us just 1 out of every 100,000 records, which would give us a total result set of 10,000 rows. As before, this is going to save the results in a variable called a few records 2. As before, we will go ahead and execute this and convert the resulting dataset into a pandas data frame. And this now gives us the subset of the data which we can go ahead and examine and clean.